This is a nice graph to draw because it's a basic transformation of a parent function, f of x equals 1 over x. There it is there. Knowledge of what our parent function looks like and what has happened to it, how it's been transformed, will allow us to draw the sketch. So our parent function 1 over x looks like this. It's not right angles, it's very gentle behaviour against the asymptotes. Oops, nearly crashed there. And it's got a horizontal asymptote sitting on the x-axis at y is 0 and a vertical asymptote sitting on the y-axis which has equation x is 0. Now I need to flip this notation into the function notation so that I can work out how to transform the graph. F of x is just 1 over x, that's there, nothing's changed. There's a minus in front and there's a 2 there. So I can see that what's happened is a flip or reflection over the x-axis and a translation up 2. So I need to take my parent function and perform those translations. I'm going to have a vertical asymptote and a horizontal asymptote, of course. The graph will have been flipped over the x-axis, so we'll now be in these two quadrants. It's been moved up 2, so the horizontal asymptote is now visible. It's gone up to y is 2, whereas the vertical asymptote is still kind of hidden underneath the y-axis. Final job, we just need to find this axis intercept here. We're looking at where the graph crosses the x-axis, so that's when y is 0. So we go back up to our function notation and replace y with 0 and solve the resulting equation. 0 is 2 minus 1 over x, 1 over x is 2, x is a half. And so now we have completely finished our sketch of this function. Moving on to the next problem, we have the function y equals 1 over x minus 3 plus 1, which is the same parent function as we had a minute ago, 1 over x minus 3, but this time it's actually been changed inside its f of x minus 3. F of x is 1 over x, f of x minus 3 is 1 over x minus 3. And we've also got plus 1 there. So by flipping that notation, we can see what's happened. It's moved right 3, up 1, and now I just need to perform those translations on the function. So it's going to have a vertical asymptote and a horizontal asymptote. It's the horizontal asymptote is now at y is 1, it's visible because it's moved up 1, and it's gone right 3, so I can also see the vertical asymptote, which is now at x is 3. The graph will be up here because it hasn't been flipped over, and it'll also be down the bottom left, but I just want to check what the y-asymptote is going to be. Not the y-asymptote, the y-intercept. So on the y-axis, x is 0, so I'm going to go back up to my function and replace the x with 0 and solve that equation to get y. Y is 1 over minus 3 plus 1, y is 2/3, which is about there. So that means I know that my graph goes down like this, and I can also find the x-intercept here by putting going back up here to my equation, putting y is 0 this time and solving the equation. So for that one I'm going to get 0 equals 1 over x minus 3 plus 1, multiplying everything by x minus 3, 0 equals 1 plus x minus 3, so 0 equals x minus 2, x is 2. And that's the end of our graph. And the final one of this type, y equals 2 x minus 4 squared plus 1, the completed square form of a quadratic. I know it's a quadratic because I can see it there. So my parent function is f of x is x squared, which, as we all know, looks like this. And I've got the f of x squared. I've got f of x minus 4. F of x is x squared. F of x minus 4 is x minus 4 squared, with a 2 at the front and a plus 1. So by flipping the notation like that, I can see what's happened. It's gone right 4, up 1. This is why the completed square is so good for us to see what's happened. You can just look at it straight away and go, right, it's gone right 4, up 1, and then the 2 just makes it a bit tighter. So rather than being quite an open quadratic, it's squashed in like that. So applying those transformations to the graph, it's moved right 4, up 1. So its vertex, which was at the origin, has gone across 4, up 1, and it now lives roughly there. And this will be the point 4, 1. The vertex we can always see directly from the completed square. And now our only remaining job is to find the y-intercept. The y-intercept is when x is 0. We go back to the equation, replace the x with 0, and solve for y. 2, 0 minus 4, squared plus 1. Y is 2 times 16 plus 1. Y is 33. That's the end of our graph.